So hi guys, welcome again to another video, and for this video I'll be summarizing the chapter 8, which is subnetting IP network. So this is the medium part of the chapter because we'll be doing the subnetting IP network, which is slight not it is a slight difficult for this to understand, but let's start. So first we have the broadcast domain. So the broadcast domains here is each router interface connects a broadcast domain, and broadcasts are only propagated within a specific broadcast domain. So let's proceed to that will be the subnetting formula. But first, let's encounter the problems with the large domains. So slow network operations due to the significant amount of broadcast traffic. So slow device operations because a device must accept and process each broadcast packet. And the solution: reduce the size of the network to create a smaller broadcast domains in a process which we call subnetting. So the smaller network spaces is what we call the subnet. And the reason why we are subnetting, because the network administrator can group devices and service into the subnet that are determined by location. So here we'll just subnet or borrowing bits from 1 to 6, and that is the value of the positional value. The 1 to 8, 1, 2, 4, 8, 16, 32, and 128. So the n will be the bits borrowed. So here are the length in subnet mask. One of the subnet is divided to 8. That is what we call the subnet, which is the smaller pieces, but it is the same value. So here is a basic VLSM. We have the network portion, the green one, so 3 bits borrowed from the 7 subnets. So we have the host portion and the dotted decimal. So we have here the ones and unused or available. So that is for the subnet, and that is for planning the address network. First, to prevent the duplication of addresses. So we prevent the duplication in creating addresses and monitor the security and performance. So we should monitor the security and performance, and provide a control access. So that is the example again for subnetting with the prefix notation 16. And this is for 16, and here is given the 100 subnets with 16 prefix notation again, and here is the host that we will be calculating. So the zeros here is 9, so we will be borrowing the 9 here. So the answer here is 512, which is we will be removing 2. So the valid host per subnet is 150. So just like here, just the same. So I'll be telling to you the summary of what it's just a fast recap. So process of segmenting a network by dividing it into a smaller network spaces is what we call subnetting. So every network has valid range of host address, and all devices attached to the small network will have a IPv4 host address for that network and a common subnet mask or network prefix. Traffic can be forwarded between hosts directly if they are on the same subnet. Traffic cannot be forwarded between subnet without the use of the router. To determine if the traffic is local or remote, the router uses subnet mask. The prefix and the subnet mask are different ways of presenting the same thing, the network portion of an address. So the IPv4 subnet are created by using one or more of the host bits, network bits. There are two very important factors that will lead to the determination of the IP address block with the subnet mask of the number of subnets required and the maximum number of hosts per subnet. So there are inverse relationship between number of subnets and the number of hosts. The more bits are borrowed to create subnets, the fewer the host bits that are available. Therefore, there are fewer hosts per subnet. The formula is 2 raised to n, which the n is the number of host bits remaining, and that is used for calculate how many address will be available in each subnet. If the network address and the broadcast address within a range is not usable, therefore we will calculate the usable number of addresses. Excuse me. The calculation of 2 raised to n minus n is minus 2 is required. Subnetting a subnet or using a variable length subnet mask or the VLSM was designed to avoid wasting addresses. So I think that's all for this video. Thank you for watching. See you again on my next video.